This is a very so what is the difference between normal list to set to and collection map? So map is not part of no that collection hierarchy. We have seen that already. So the reason is list to set you can store only one element directly, one object you can store. But map is not like that. Map is different. Map is different. So map basically it going to store key value pair. That's the map. Key value pair is going to be stored. That's the map. So please work on all these exercises, okay? All these exercises. So these are exercises are there, right? So work on all these exercises, okay?
Okay, sir.
All these programs and practice and send it to me. So these are the programs you have. And this is another program, so you can, so these programs also you work on them. So this is another interview program that I already discussed. We just see that. Next. So what is a map? So why it is different than list and set? So list and set, you can store only one element, but there is no reference for those elements. But map is not like that. So map is a key value pair concept. So every value has a reference, that is key. Every value has a key. Each key and value pair is known as an entry. Each key and value pair is called an entry. One key value pair is one entry, we call that. Like that, you can enter multiple entries into the map. So the default size of map is 16 buckets. 16 buckets. Each bucket you can store multiple entries. So if 1/3 is filled, automatically your one more 16 will be added automatically. Like that, it will keep on increasing the map size. So why do you need a map? If there are already list set, why do you need map again? If you want to search, update, delete elements based on the key, then you can go for map. So every value you need to give a reference. That is key. If you want to key and value concept you want to bring it, so then go for the map concept. So there are two interfaces, map interface and sorted map. And three classes are there, HashMap, linked HashMap, and tree map. So this is the hierarchy. Map interface is implemented in the HashMap, linked HashMap, and tree map classes. So map is another, you have sorted map. So these are implemented in the tree map. So map doesn't allow duplicate keys. So always map is going to have unique keys only. But values can be duplicate. Key should be always unique. Key always going to be unique. So that's the main concept of a map. So HashMap and linked HashMap classes allows null keys and null values, but tree map doesn't allow any null key or null value. So map directly can be traversed, that means iterated, So you need to convert the map into set collection. That you can do with a key set method and entry set method. Key set will give you all the keys. That will be return type is a set collection. Entry set method returns all the entries of set collection. So these two methods you will use widely. So these are the classes: HashMap class, linked HashMap, tree map. These are the three classes implement the map interface. Map is an interface. Map is an interface. So HashMap is the implementation of a map, but it doesn't maintain any order. Same HashSet also doesn't maintain any order, right? Because they store in the hashing concept. So map also stores in the hashing concept only. Linked HashMap. So this is the implementation of map. This is also implementing the map interface inside the linked HashMap class. So it inherits the HashMap class and maintains the insertion order. So HashMap doesn't maintain the insertion order, but in linked HashMap maintains the insertion order. Tree map is the implementation of map, sorted map. It maintains the ascending order. So it maintains the ascending order. So it will place the elements in the ascending order. That's the, so map and other three classes, which classes, and what are the methods of a map interface? Map has some methods. How can you insert the entry into the map? Using put method. Put object key, object value. You can insert key value pair into the map using put method. Put all method. You can join one more map with this current map. That's a put all method. We have seen add all to insert to join the two collections, to list collection or to list collection or set collection. You can join with the add all method. But how can you join two maps? Using put all method. Next, put if absent. Put if absent. So put if absent means so that means if it insert the another entry. What is meant by this? This put and this put, both are inserting the elements. Basically, the key, if already present, right? It won't insert. If it is not there only, it will insert. That's a condition-based method, this one. Remove. So you can delete the entire entry with the remove method. How can you delete the entry from the collection from the map? Means you have to use remove method. Or you can use a key value pair both. If you give the key here, it will delete. There is one more overloaded method. Key and value both if you give, that also delete the entire entry from the map. key set. It returns all the keys into set collection. Entry set method. So this is the return type. Set map dot entry and KV in the angular bracket. That means K means key data type, V means value data type. You have to specify. So this is the entry set method. So all the entries will be returned to you in the set collection. Okay. Now, key set we have seen, entry set. These are the very important methods. Next important method we need is contains value. So whether this value is present in the map, if you want to search or check, you will use this one. Or contains key, both value you can check and key you can search in the map using these two methods. These will return a Boolean value. So these two are another important methods. And then equals, very important method. So you can compare this object with a map element. So that's the equals method. So how can you get the value from the map? Using get method. So get of object key. If you give the key and that value, it will fetch by get method. Get or default means the default value also it will fetch. And generally you can use this method. Hash code method. See, this returns the hash code value of the map. So these two methods equals to hash code methods are important. These are coming from object class and they are overriding here in the different classes. So next important, yeah, those are the very important methods. So there is a map.entry subinterface, so which has some values you can get key returns the key name, get value returns the value. So if you have an entry, right? You have an entry. That entry means key value, right? So the key name you need to get. How can you get? With a get key method. How can I get the value? With a get value method. So that's the get key and get value methods you can use. Okay, so that's the HashMap class. Next, HashMap class. So we already discussed. So it is implementing the map interface. So you can see HashMap extends abstract map class and implementing the map interface. So HashMap class implements the map interface by using a hash table. It inherits the abstract map class and implements the map interface. So HashMap class implements the map interface. So by using hash table concept, hash table is a very old class. So it inherits the abstract map class and implements the map interface. So what are the different points you need to consider when you are working with HashMap? HashMap contains values based on the key only, not only value. So that is a list and set contains only values. But here map means, HashMap means it contains the values based on the key. HashMap class contains only unique keys. HashMap class may have one null key and multiple null values. HashMap class is non-synchronized. HashMap class maintains no order. See, hash map is non-synchronized. It doesn't maintain the insertion order. Hash map class may have one null key, multiple null values. So it contains only unique keys because map contains unique keys only. This also contains unique keys. So the hierarchy of hash map class, you see this public class hash map, key data type and value data. This is the generic. Extends abstract map, key data type, value data type in the generic format. Implements map, clonable, serializable interfaces. All these interfaces are implemented in these classes. So hash map class, I already told K means type of key, V means type of value. So that's the hash map. You have three constructors. So 1, 2, 3, 4 constructors total. So default constructor, parameterized constructor, parameterized constructors. So these methods we already discussed. Now again, we don't want to discuss. So here is the one. If hash map is available, then why do you need hash set? So what is the reason? So this is another interview question. So you can explain easily, right? So hash, I already told hash set. So both are different purpose and have distinct use cases. So even though they use the hashing technique to store the elements, but the way it performs is different. The use cases are different. See, HashMap uses a key value data structure that allows you to store and retrieve values, so all associated with the keys. So it associates each key with a specific value, so making it a suitable relationship between keys and values. So common use case for HashMap is, so includes storing configuration settings, caching, representing relationship in data structures like graphs. And when you need to associate values with a specific identifier or keys, HashMap is a good choice. So this is how you can create HashMap. Map, key data type is a string, value data type is integer. A is map. New hash map. So age map dot put. So name and age. So name and age. So you can get that, see, with a get method. You can retrieve age of Alice, right? Just key you are giving. This is the key. Alice is the key. And you will get a 25 here. That's the hash map. So, but the hash set is unordered collection of unique elements. So typically used to ensure the collection contains no duplicate values. It stores only unique elements. So you will use this hash set. So if you want to check for the presence of an element in the collection without regarding its position, so then you will use hash set. So there are hash set include implementing sets and ensuring uniqueness in a collection of items. So you want all the elements unique, no duplicates. Then you will go for the hash set. So when you need to maintain a collection of unique elements or efficiently check for the presence of an element, so hash set is a suitable choice. So that's the hash set purpose. You want to store unique elements, you want to search unique elements. All this can be done with the hash set only. So this is the hash set. Set string unique names equal to new hash set. Unique names dot add Alice. Unique names dot add Bob. So Boolean contains Alice. So you can this set collection dot contains Alice. Check if Alice is present or not. So you'll get a true here. So while both HashMap and HashSet use a hash-based data structure, but they have different purposes. So HashMap is used for mapping keys to values. HashSet is used for maintaining collection of unique queue elements. So choice between them depends on the specific requirement where you are using them. That's it. Other than that, both are different and the purpose is different. Okay. And another very popular interview question, even for Java developers, for everyone. So you need to explain how HashMap works internally. How HashMap works internally. So as I already mentioned here, the little bit clue I have given already. So when you create a hash map, then 16 buckets will be created in the heap memory. So because this is the object, right? This is the object. So heap memory, the memory will be created for this map. So only 16 buckets. Yes, initially 16 buckets. 3/4 is filled. 75% of no, your buckets are filled. Then it doubles their capacity. Automatically doubles the capacity. So you already know what is linked list. Linked list means there is a node, okay? So it stores the data in the form of buckets. So bucket is nothing but, so it's a linked list. Each bucket is nothing but they're like this one. This is the one bucket, right? The bucket inside you have a linked list. So each data, it is linking. So this is called one node. This one small box, this is called one node. So this is pointing to another node. This is pointing to another node. This is pointing to another node. So let's see what happens when we add nodes to the linked list. So start item 1 pointing to item 2, item 2 pointing to item 3. So this is all the elements, so linked list elements. Now see, this is how your hash map looks like. So 1, 2, 3, 4, 16 buckets will be there. So this is the one node and the same index you are getting. Here only one more entry if you want to store, one more node will create. So if this entry and this entry different, then one more node will create. And one more entry adding to the same bucket, one more node will create. Like that, your linked list will grow. So that is how it will store the elements in the map. So let's see one by one. Suppose you have take the put method to store the key value pair, right? And so how it will insert into the map. So when you call map.put key and value, so both are strings. First key, this is the key. This one is the key. This value is A. So now first step is you will calculate the hash code of any key, the first whatever you are entering. First you will find the hash code. That's the first step while inserting the elements. Find the hash code, fb dot hash code. So suppose you got 2236 is the hash code for this fb value, fb key. Now with this hash code, you will find the bucket index. There are 16 buckets, right? Which bucket this value should go? This entry should go. So you need to find the bucket index. So that to calculate, you will use first step hash code ampersand length -1 if you do, and you will get the bucket index. That is, suppose you got a 12th bucket. Now this value will go and store in the 12th bucket index as a one linked list node. So that's so bucket index 12. So this is the 12. 0, 1, 2, 3, 12. So 12th bucket, this value, when you call put method, those above two steps will perform and it will store the value like this. First node linked list. So FB and A. Hash code of FB. So index 12. So take one more key value pair, okay? So now one more key value. So LD and B. Now what is the first step again? First it will calculate the hash code. Now you got a 2424, suppose. And then with this hash code, you find the bucket index where this key value pair should go. So you got the bucket index 8. Now in the bucket index 8, so you don't have any elements. So that will go and store there. So bucket, it will store there. So this has some problem. Okay. Now, so 8th bucket, it will store. And add one more element. So to already now 12th bucket and 8th bucket, we stored already. So now 12th bucket, one linked list node is created. And 8th bucket, this linked list node is created. LD and B went and stored in the 8th bucket. 12th and 8th buckets are having values now. Let's add one more element to understand hash collision concept. What is hash collision? Hash collision means already the linked list node is present in the particular bucket. And you are trying to place one more data set in the same bucket index. Then, so there is a hash collision concept comes. So what is hash collision? The bucket is having already one node. That means one data set is inserted into the bucket. And again, JVM tries to place one more node in the same bucket. That is called hash collision. This is a very important interview question. What is the hash collision? Bucket is already having a one node. And again, JVM tries to insert one more data node in the same bucket. That is called hash collision. Hash collision takes place. Now, suppose EA and C. So you got the hash code 2236 for this EA key. And we are finding the bucket index. You suppose you got again 12th bucket. Already 12th bucket has a, so one element already, one node is there. Now, this element, this entry also going to same 12th bucket. Now, how it will place? So that is the one you need to understand here. See, FBA is already placed. Now, one more EAC already got the same bucket. Now, how it will place? So, JVM first checks if same key is present in the bucket or not using equals method. See, hash code method, equals method we are using here. If same key is present, then JVM will update the existing key with a new value. So now check. This is the FB key. This is the EA key. It will compare. EA equals FB. True or false?
True.
True or?
Oh, sorry, false.
False, sir. EA value key is different. FB key is different. So already FB is here. So it's not same. So one more node will create here. New node will create. So that will point to another linked list node. That means your linked list is growing here. If keys are not same, existing key and what you are entering key, both are not same, it will add one more linked list node. So this value will go store in the another linked list node. Now, see that if the existing key is not equal to new one, then new data will be added like this. So same bucket, another linked list node will add as a second node. Now you can observe that linked list is growing here in the same bucket. So if it is equal, what will happen? If it is equal, the value will be updated, not the key. Key is the same, you're saying equals. Now here key is not equal, that's why a new node is added. But if the key is same, value only will be updated with a new value. So that's the difference you need to understand here very clearly. So if keys are same, what will happen? If keys are not same, what will happen? If keys are same, the value will update in the same linked list node bucket index. If values are not same, the keys are not same, a new linked list node will be created in the same bucket. So that another node will create. So the summary of entire key value pair inserting is, so when you call the put method, first it will find the hash code of the key. That's the first step. The second step is find the bucket index using this hash code. And then, so it will check hash collision. Hash collision means, so if hash collision means, that means the same key value pair is going for the bucket index, which is already there, one more entry. So that is called hash collision. If hash collision S occurred, then what will happen? So then equals method will call. So equals method will check existing key and a new key, both are equal or not. If not equal, new linked list node will create in the same bucket. If yes, so same value will be replaced with a existing value, a new updated value. If no collision, simply add to linked list as a first node in another bucket index. That's it. This is the summary of entire concept. Suppose how search will happen. How search will happen in the linked list. So one by one node will search. That is a drawback of linked list. It reduces the performance basically. So item 1 is equal to item 2. No. Again, item 1 equal to item 3. No. Item 1, just like this, one by one, keep searching. So that's the problem with this one. See? So you want to search with item 3, you want to search. So item 3 equal to item 1, item 3 equal to item 2, item 3 equal to item. So it will keep searching each node. So that will take more time consuming. That's a problem and it reduces the performance. So that's a linked list problem. How will you get the key value in the hash map? So you can get the key value like this again using a get method. So map.get EA, first get the hash code of the EA, then find the bucket index of EA. Where this EA is there? So EA is there here. First it will search in this linked list. Node, again it will go and search in this linked list. Second node, so it's available and it will fetch this C value. That's how you will get the get method, how it will go and search. So because each linked list node, it will search. So that's all about how hash map works internally. This is a very important concept. So we will know. So discuss this simple hash map and hash table difference. Then we'll close today. So hash map and hash table both are used to store key value pair entries. So one entry, if you want to store, you will use that. So both use the hashing concept only to store the unique keys, but there are few differences. HashMap is non-synchronized. It is not thread safe and can't be shared between many threads without proper synchronization code. So hash table is synchronized. It is a thread safe, can be shared with many threads. And HashMap allows one null key and multiple null values. Hash table doesn't allow any null key and null values. HashMap is, so it is introduced in JDK 1.2. Hash table is a legacy class, very old. HashMap is fast, hash table is slow. So we can make the HashMap synchronized using collections utility class dot synchronized map method. But hash table is internally synchronized. You cannot unsynchronize that. Hash map is traversed by iterator. Hash table is traversed by enumerator and iterator both. So iterator in hash map is fail fast. Enumerator is so not fail fast. So hash map inherits the abstract map class. Hash table inherits the dictionary class. This is the one of the famous interview question, this one also. Okay. So a lot of theory part and also programs also they will ask in these collections. So more number of times you have to read, then only it will be easy to remember them. Otherwise, it's a difficult. Okay.